Hello to everyone that joined and welcome again to the webinar Electronic Lab Notebooks Under the Spotlight. My name is Jana. I'm a product manager at SciNote. And the aim of today's webinar is to answer as many of your questions that you have about ELNs in general. So whether you have just started to think about using one or you're actively searching for a solution, we want to give you an objective answers to your questions. Send us your questions at any point during the webinar and we will answer them during our Q&A session following the presentation. So let me introduce our speaker. So Klemen Zupancic is the CEO of SciNote, open source electronic lab notebook. Klemen will give us an overview how research data is currently being managed and how this will change in the future. So most of the webinar will be dedicated to the Q&A session, during which he will answer your questions about ELNs and also address the concerns that you might have. Klemen, the stage is yours.
All right, so thank you, Jana, and thank you to everyone that took the time now to listen about electronic lab notebooks and what we see is coming in the future. So let me start my presentation. Okay, so I hope this works. All right, so the title of the presentation is Electronic Lab Notebooks, or Under the Spotlight, or how we like to call it in short, ELNs. So today we'll briefly cover, so before we go into the questions and answers, we'll briefly cover what are the current challenges with digital data management in science. What are the biggest challenges from going from paper to electronic notebooks? So what are the pros and cons of having software, whether having the software in the cloud or having it installed locally or on a PC? And what we can expect of the future, what's coming in the future. So it's not surprising that we have 54% of studies that cannot be verified. So what this means is, if you take any paper in any publication, it's 54% likely that you won't be able to use the raw results produced in this paper. So this is not because there are so many scientists that do bad science, but it's because the science is not recorded properly. The data is not managed properly. And if you add to this that the scientific output doubles every 3 years and that 17% of the data is lost every year, this is not a surprise. So what this means is, for example, you find a study that's exactly relevant to what you are trying to research as well. Before you find this person to send you raw results, maybe you'll be interested in some special details that are hidden away in the paper notebook that this person used, and so on. So before you find this person probably moved to 3 different positions since then, since the publication. You cannot find the data about the temperature where the samples were stored and so on. So it's not really comparable, and you cannot really verify the results of the studies. So why does this happen? Well, one of the drawbacks is that we are recording the scientific process the same way we were recording it 100 years ago. So if we are using paper notebooks, it's impossible to connect them to all the digital data that we produce at the same time. So if I'm doing measurements, I have to store Excel spreadsheets somewhere, either on my laptop or on a server of the university. But it's hard to connect those spreadsheets to my paper notebook unless I'm printing them out and pasting them inside of a notebook. But with the growth of data that we've seen, this will slowly become impossible because just the sheer amount of data that we produce, the paper notebooks simply won't be able to handle. And don't get me wrong, we love paper. There are many benefits to paper notebooks. For example, they don't need batteries. They're very long lasting. They're cheap. everybody can use it. There is a very short learning curve how to use it, but there are many limitations as well. For example, it forces us to have sort of a linear thought process when we're doing science, because you put the entry of what happened today, and then tomorrow you'll put an entry what happens tomorrow, and so forth. But science, it's not like this. You always go some direction, you come to a dead end, come back, retract, grow from that. So it's much more of a scattered approach. And when you add collaboration to this, then paper is just a limitation in the process. Because of this perception, we wanted to understand what is the scientific community doing about this? So how they see the perception of electronic lab notebooks? Do they see them as a solution? Do they adopt them already? So we did a study where we asked a simple question. So are you using ELN in your lab? So 8% of people answered yes. About 6 to 7% of people were budgeting for it. And then in the first study, which was done early 2015, 40% of scientists said that they're thinking about it, and 60% said that they were, just a year later, 60% of them said that they were thinking about it. So we believe that this is due to this increase of digital data. So more and more everyday scientists have problems with digital data management, and they're looking for solutions on the market. So what should an ELN be like? So we ask the users, what are the features that you would be the most interested in? And we asked them about very specific features, and what came out was a bit surprising to us, but by far the most important feature for everyone was easy to use software. So scientists are in some sort afraid of transitioning from paper notebook to something very complex. So an ELN should be something that is really easy to use. Second was safe, so the data is safe and secure. And we've seen that not a lot of people are budgeting for it, so it should be free or at least very affordable. And then is the challenge. So as the scientists mentioned, the easy to use software, ELN being easy to use, is one of the most important features. That's because we have the perception that transitioning to paper notebook is really complicated, to electronic lab notebook is complicated. And yes, there are changes to existing habits that you need to do. So another thing that we asked our users was what are the biggest barriers in the electronic lab notebook adoption? So apart from the obvious limited budget limitation, changes to existing working habits was second on the list. So yes, there are things you will have to change if you transition to electronic lab notebooks, mainly how you enter the data, but think about what other things changed in the past, especially in which other areas of your life you were forced to switch to digital. So for example, it started with email, then smartphones, messaging, Facebook. So we use so much electronic tools already. And yes, there was a transition period, but once we are there, we can see all these benefits from their analog predecessors that we wouldn't even think of using something else. Similar thing will happen with electronic lab notebooks, but an important point to make here is that manufacturers of these ELNs will have to come halfway, and creating tools and software add-ons that will make it much easier and much more streamlined for you to change. So for example, to get all your protocols digital, to get to be mobile, so that you can use a tablet computer in the lab when you're writing things down, and so forth. So what are the pros and cons of a cloud software versus desktop software? So desktop software, meaning software that is installed on your computer, on your PC, and then run just locally. So there are many pros of using a cloud-based system. Namely, you can be a lot more mobile with that. You can share the data much faster, much easier with others. You can access the data from multiple laptops, phones. You can access it from home, from work, if you travel to conferences. So there are many benefits of having an ELN in the cloud, but a lot of scientists are concerned about the data safety and data security. So let's talk about data safety for a second. So what nobody wants is to wake up one day and realize that, oh my God, all my research data, so all my Excel spreadsheets, all the exports from the instruments, everything has been deleted, and I have no idea how to come back. I've spent years of my work doing this. So this is what nobody wants. But this is something that can happen. So this is important to understand. This is something that can happen to you regardless of where you keep your data. So all the storage media have their limitations. So even if you store all your data on a USB drive or on your PC, there is a chance that the hardware will crash and just one day you won't be able to access any of it. So it's really good to have backups, and cloud software systems are much better with making backups, spreading them around the world. So even in case of larger disasters, you are much more likely that you'll be able to retrieve the data safely. Another aspect is that there is a time limitation. So a lifetime of, let's say, hardware disks is about 5 to 10 years. So if you want to be a good data manager, you have to change those every 5 years. If you're not doing this, you're dramatically increasing these risks again. So having data on the cloud, all of this can be automated, and a lot of ELN vendors also offer the automatic backups of data that all the data will be backed up on your computer just in case the vendor goes bankrupt or something happens to the server and you don't have access anymore. So that's about data safety. So data security, a lot of people are concerned about the data that they put in the cloud, because once it's in the cloud, everybody has access to that, and you just need a hacker to hack into that system, and they'll be able to get your data, they'll be able to patent your research, they'll be able to publish before you do. So this is a legitimate concern, and there is, again, an important thing to note is that there are no hack-proof systems. So you could hack into any system that's out there. That being said, as long as you're storing your data on a computer that is connected to a local network, it means that somebody can just as well not to the local network, to internet. It means that just as well as somebody hacking Amazon could easily hack your laptop. So one could argue that, who am I to say that my personal computer is safer than Amazon servers? So Amazon has, probably thousands of security engineers employed whose single worry is, that people won't hack the data. This changed a lot. 10 years ago, it was much less safe to have the data much less secure to have the data in the cloud. But nowadays, if you think about it, we do all of our banking through the cloud accounts. So all of our money, all of the government things, everything is done over the cloud. So it's just the perception of, can this cloud be secure enough to do science? And my personal opinion is yes, for quite some time already. So what can we expect in the future? There is the Internet of Things revolution, if you will, that is coming to not just to science, but to to every part of our lives. So all the devices are now connected. You have the phone that can talk to your car, that can talk to your television, and so everything is connected, which is very convenient. So this same thing is coming to the lab. It's to some extent here already, because we know that you can connect your minus 80 fridge to your phone. So whenever the temperature changes dramatically, you would get an SMS. So there are small elements that are getting connected. But if we really want to connect all the devices in the lab, then ELN is a great way where to start. An important thing is that if we want to connect all of these devices, we will have to standardize the way that these devices talk to each other. So standardize the way that how the data is created, how the data is shared. And a lot of this can be done by opening up. So I'm not just talking about open source software, I'm talking about open standards, open APIs. So anything that will help other vendors connect their devices to your device, and not just them, but also scientists. So we want to give the freedom to the scientists that they can do the connection and that they are not vendor dependent. So what I mean by that is that when you decide which instruments to buy, you don't have to buy the instruments from the same vendor, but you will be guaranteed that once you buy an instrument, you'll be able to plug it into the whole system, the whole network, and everything will work. So this is where I personally believe ELNs will play a big role in the future with just automating and automating our lab and making it smart. So that's it. That's it from the presentation. So I'd be happy to take your questions at this point.
Okay, so thank you very much, Klemen. So like you said, we are now moving to the most important part of today's webinar, so your questions. The first and for now the only question we got is so somebody is asking if the sharing of data and recipes, so the protocols, is already state-of-the-art in ELNs. So is that a general feature?
That's a really good question. It's where it's protocols. It's where it all starts essentially. So if you want to do experiments, you need to know what you want to do. And the answer to this is, let's say 90% yes. So a lot of electronic lab notebooks have built-in functionality of protocols that you can create databases of protocols. You can share the protocols with others. You can version them. So this is another important feature that you want to look in. Is that, for example, if I use a protocol that my coworker used, I can make some changes, and I'll see where I made the changes, what was different, connect the results to that protocol, and then after some time, I will have the entire evolution of that protocol. Maybe it will branch out into two different protocols, and with this it will get better, and not just better, but it will be traceable of why we made certain choices that we've made for one over another. One other thing I would like to add is that when you start using an electronic lab notebook, you will have to put in your protocols by hand. This is changing as well. So there are some initiatives that are already gathering the protocols. So that are already gathering the protocols of users, putting them together, putting them in the sense of getting the best protocols out there from the community, and ELN vendors will definitely help the ELN vendors, because they will just simply be able to pull these protocols from the internet into the electronic lab notebook.
Okay, so Klemen Patrick is asking us a question. So can you describe an example of IoT device and ELN working together?
Okay, that's a great question. So as I said, what works at the moment is, for example, you can have small things like fridges connecting to your phones. But what can be happening in the future is that, for example, you can start with liquid handling. So just by knowing which samples you have, so by, for example, walking with your phone next to the fridge, you'll be able to see on your phone or on the tablet exactly the contents of the fridge. You'll be able to choose the samples from that fridge, send them to an experiment, and for example, the liquid handling robot will know exactly what to do, how to pipette them, because it will know the number of samples, it will know the protocol that you want to do. And once the robot is done, you'll just transfer the let's say the microtiter plate to a device which will do the measurement. Again, the device will know the protocol, it will know the parameters that it needs to know to do the measurements. This will get sent to the central data repository. So just by doing a few clicks and just by walking through the lab, you'll be able to design, create, and execute the entire experiment. And then once you have the data there, a lot of things, so you could do a lot of things of having the data centralized. So for example, you could use an AI algorithm to design your introduction to your scientific paper. All the materials and methods are one click away. All the results are one click away. The only thing you have to do is write the discussion, right? Which is exactly the point where you add value as the scientist. So the idea is what Internet of Things can do is automate the entire lab on one hand, and then on the other hand, makes it a lot easier and faster for us to publish science, to collaborate, to share the discoveries, and so on.
Okay, so Ferdinand has a question about protocols. So I guess they are about actually using SciNote. So he's asking what kind of file you should load to the protocol step. Is this a text file or any other?
Okay, that's another good question. So I assume that your protocols are at the moment in PDFs, which is where most of scientists would keep, how most of the scientists would keep their protocols digitally. So the easiest way is just to upload a PDF and just follow it. However, this gives you very little smartness, quote unquote, to the electronic lab notebook, because then the electronic lab notebook only knows about the file and not the contents about the files. So if you want to use ELN in its true potential, then there is a big chance that you'll have to rewrite all the steps manually, or copy paste them. That being said, as I said before to the first question, there are multiple platforms that are now emerging. We are doing some of that with SciNote as well, where we want to collect the existing protocols that users are doing, make them perfectly fit to the electronic lab notebook version, and then you'll be just able to search for a protocol online rather than type it and scan the PDF and so on.
So we have another question related to SciNote. So are there any tutorials available? So
yes, so that we have currently 4 tutorials plus one, let's say, overview tutorial on our webpage. So if you navigate to SciNote.net under products, you will see tutorials. And if there is anything unclear, just make sure to contact us, and you'll be able to speak to someone that can answer any detailed questions you might have.
Okay, so we have a great question about open source. So I like the idea of an open source to develop my ELN further. However, I have doubts as I don't know many experimental scientists who can properly code. So how can I ensure functionality?
Okay, that's I think what really nails the whole problem. That's the general concern of the open source in science, right? Because there is the strong element to having open source software is that the users are empowered that they can build their own things, but unless you can code, you actually don't have that kind of power. So that's very true, but there are a couple of elements. There are a couple of other elements to this as well. So open source, it's not just that empowers you as the user, it forces the community. And I'm not talking about just the scientific community, but also the community of vendors. It forces them into a different kinds of business models and gives more leverage to the user. So for example, if we as a company with an open source product say that we suddenly want to charge extreme amounts of money for the support of this software, you have the power and say, you know what, we'll just take the code and we'll hire somebody else for the support because they will have the look into the software. So that's just one example. The thing is that even if you can't code, you have free hands and you're not dependent on the company to do any changes of the software. So that's pretty much the added value. Another thing I'd like to add as part of this discussion is that, for example, and this is my personal belief, as a scientist, my lab notebook was such a basic tool and is such a basic tool to every scientist that having it all done under an open source license just gives sort of the transparency to the product that such a company providing this should do, right? So that you as an end user are involved essentially in the evolution of the product. You are involved to some extent into the decision making of the product, and I think it's where a lot more software in the future is going to go that direction, more for these reasons than for reasons that you have to be a coder to really appreciate open source.
Okay, so we are back to interoperability.
Mm-hmm.
So are ELNs currently connected to, let's say, recording devices? So, for example, microscope, maybe qPCR machines. So basically, they could automatically push the data to ELN in some sort of standardized format. And when do you foresee this?
Okay, so that's another really good question as well. So if I had to answer that question with one word, I would say poorly. So ELNs present this great opportunity how this could be done. However, there are just so many instruments out there that it's impossible to say that an ELN is compatible with microscopes. It depends which manufacturer, which type of microscope, what kind of data from microscope you can do. That being said, this is improving, and there are other companies that are just doing the integrations with instruments. Usually ELN vendors offer the integration with instruments as well. So ELNs are inherently designed so that they will be able to connect to more and more instruments. If you're using an ELN already and you have an instrument that you'd like to connect to it, I'd suggest you contact the vendor of the ELN. It might be easier than you think, but it's very likely that it's not off the shelf.
Okay, so we have one SciNote user here as well. So, he's wondering whether he can download the data results comments of a project, so within the project, all at once.
Okay, we get that question a lot. So as you also specified in your question, so at the moment, if you want to download everything at once, is only possible in the PDF view. But we've put this very high on our development list, and this is a feature that's coming up in SciNote, that you'll be not only able to download everything, you'll be able to maintain the folder structure the same that you've organized within SciNote. Plus, you'll be able to schedule your downloads for automatic data backup on your PC, something that I've talked about, something that some ELNs already have. But so this is coming up. If you're using SciNote, please bear with us, and we'll notify you as soon as this is possible. And yeah, basically, once this is possible, you'll be able to download all the existing data that you've already put inside.
Okay, so we have no questions pending at the moment, and I'll ask a question that we hear very often. So people are asking, what's the price difference? What's the difference, between cloud and offline installation? So, scientists would really like to keep their data, like we said before, on their own servers, and they automatically said, okay, I want offline. So can you explain the difference between cloud and offline in terms of the pricing, and why is the difference?
Okay, so one of the biggest differences, and this is not always the case, but one of the biggest differences is the business model. So usually cloud-based providers will have a sort of service fee. So you'll pay for software as a service. This means you'll have to usually subscribe for a monthly subscription, and you'll be limited with the number of users. That's usually how it works. Whereas if you have a downloadable software that you can install and just run locally, you'll probably be charged a one-time payment. So this is changing as well, and you may get a one-time payment contract for the cloud service, and you can also get a subscription service for the downloadable software. But this is something that I see that is the biggest change. So and then this relates also to so you'll probably, if you're using a downloadable software, you'll probably end up paying more at the beginning, but then with time the costs will drop. Whereas with cloud software, you'll be able to you'll pay little, let's say, but you'll pay monthly. Maybe an important thing to note here is the difference of, so why would you go one way or the other? So apart from the reasons that we discussed with the cloud versus local, there is a difference to approach. So if you're using a subscription-based software, it's very likely that all the updates and everything will already be included, so that each month that you pay, you'll have the latest version of the software. This is getting more and more important because the software landscape and even the instruments in the lab and so on is changing just so rapidly that you want to make sure that you have the most updated version all the time. So with offline software, with something that you pay once, it's likely that you'll have to, so you have to read the contract. It's likely that you'll have to pay for updates, at least after a certain point in time, which is something that you should take into account. The bottom line is, I think, on the long run, you'll be paying, same amount of money for the value that you're getting.
Okay, so and can you explain a bit more? So let's say, what is, for the use case, so what is the benefit of an ELN for a professor?
Okay, so that's another question which we are getting a lot more into lately. So it's the question of scientific collaboration. So how do we leverage scientific collaboration? Like 100 years ago, you could easily publish a scientific paper alone. Nowadays, at least in life sciences and chemistry and so forth, this is practically impossible. Like we practically don't see those kind of examples anymore. So if we want to do science the modern way, we are forced to collaborate with others, which is great. This is how we can build upon each other's knowledge and produce great results. This means that this is another great point for why you should be using an electronic lab notebook, right? Because you want to collaborate with other scientists, and when you have an electronic platform, this is much easier. And if you don't believe me, just remember that time when you had to, go through the paper notebook from, your colleague at work. So that being said, professors have, this is what professors are dealing every day when they're giving lab assignments to students. Basically, they're collaborating with scientists that are, very unpredictable in how they will behave. So the collaboration aspect is really important to them. And the other aspect to this is that, the students that professors are teaching at the moment, when they are, in the age of, actually working for companies or working for other research institutes, it would be wise that they at least have some sort of experience with dealing with digital data. So this is the problem that, when I was in college, nobody was talking about this because it wasn't a problem. So it's a problem that happens now. And I think the modern day professors should be aware of this problem and at least give some insights to the students on how this problem can be tackled, what are the existing approaches, what they believe the future is bringing, and give them some tools or at least some instructions how to leverage this kind of collaborative tools and digital tools.
So maybe to add here, so what I also feel is important. So professors, so the students are leaving the lab, let's say after 2, 3, 4 years. So after somebody leaves the lab, the data stays in a paper notebook at the moment. So if you have them stored, so the data electronically, then the professor has the insight, a keyword search, and they can find the data very easily, even after 5 years after somebody left the lab. So I think this is also very important to know. So then you can also compare the data from, let's say, 5, 10 years ago, which is very valuable.
I think we have another question.
Yeah, great. So can I use ELNs to plan my practicals I'm hosting in my lab for supervising and plan experiments with pupils and students? So large and temporary user group.
So you can definitely use ELN to do that. We actually highly recommend to professors that we meet that they should use an ELN for this. With a lot of ELN vendors, you can get a special discount if you're a professor, if you're a teacher. It's definitely possible with SciNote. So if you just give us a shout out, somebody will contact you and will tell you how to get started. So, but that being said, to answer your question, yes, you should definitely look into this. It will make your life much easier on the long run.
But does that need cloud solution then?
I would say that's not necessary, but I think it would be highly beneficial because you'll be able to, let's say, monitor the students remotely. So this is beneficial when you're not physically there, and you'll be able to see in real time what they're doing.
Okay. So do we have any other question? I guess not. So our 45 minutes have passed. I would like to thank everyone who joined today. Again, we apologize for the last minute change. This was not in our power so it was not in our power to go to the webinar jam. They had some technical problems. So I would like to thank Klemen for sharing his knowledge with us. And I would like to thank all of you for joining this webinar despite the busy schedule. So the webinar recording will be available on YouTube, and we will also send the link to today's webinar. And feel free to share it with your friends and give us any feedback or send additional questions, so we will be happy to answer.
All right. Thank you, everybody. Thanks for your time.
Thank you.
Bye.
Bye-bye.